You live on a planet nestled safely within the solar system. But have you ever wondered what's above and below us in space? Scientists have uncovered something extraordinary, something that could completely reshape how we think about our position in the galaxy. By the end of this video, you'll see our solar system in a way you've never imagined before. Imagine zooming out from our solar system. At first, it might feel like we're leaving behind the familiarity of planets and moons, entering an endless void. But here's the thing, space isn't empty. The first thing we'd encounter beyond the solar system is the galactic plane, a dense, flat disk crammed with stars, gas clouds, and cosmic dust. This is where most of the action happens in the galaxy, a kind of bustling central hub filled with all the ingredients for star formation. Now, above the galactic plane, everything changes. Move just a short distance outward, relatively speaking, and the scene starts to thin out. Stars are fewer and far between, and the structured disk gives way to something more enigmatic, the Galactic Halo. This isn't a flat plane like the Milky Way's disk. It's a massive, spherical region that encapsulates the galaxy, stretching far beyond the visible stars. Here, you'll find ancient stars, ones older than the Milky Way's spiral arms, and hints of something even harder to pin down, dark matter. Dark matter is invisible. We can't see or directly detect it, but we know it's there because of the way it influences the movement of stars and galaxies. Scientists use tools like gravitational lensing to study it, where the pole of dark matter bends light from distant galaxies. It's like trying to figure out the shape of a glass bottle based on how it distorts water inside. And the galactic halo is packed with mysteries like this. Ancient globular clusters, tight groups of stars, float through this region, remnants of a time when the galaxy was still forming. What's even more fascinating are the patterns scientists are uncovering in this halo. Recently, research has suggested that unknown forces, or perhaps unseen structures, might be stretching and shaping the movements of stars here. These findings could redefine how we think about galactic formation itself. But if you think this is strange, just wait. Below the solar system, in the quieter regions of space, lies another reality entirely, a galactic underworld filled with dead stars and forgotten remnants. Let's explore that next. While the space above holds mysteries like the galactic halo, what's beneath the solar system might be even stranger. Beneath the galactic plane lies what some scientists call the Galactic Underworld, a quiet yet eerie region littered with the remnants left behind by once powerful stars. It's here that the real story of stellar death and destruction plays out, hidden from direct view and shrouded in cosmic silence. This underworld is dominated by the remnants of stars that have already lived their lives. Neutron stars, the incredibly dense cores of massive stars that exploded in supernovae, can be found here. A single teaspoon of a neutron star would weigh as much as Mount Everest. There are black holes, regions of space where gravity is so intense that not even light can escape. What makes these objects especially enigmatic is that they're almost impossible to see directly. They don't emit light, and without advanced tools, they could pass through the galaxy completely unnoticed. To uncover these hidden remnants, scientists rely on innovative methods. Gravitational wave detectors like LIGO and Virgo can pick up the faint ripples in space-time caused by events such as two black holes merging. X-ray telescopes are another crucial tool. They can detect the high-energy radiation emitted when black holes or neutron stars interact with nearby matter, like a passing star or a gas cloud. These tools have revealed a chaotic underworld teeming with activity despite its hidden nature. One of the most surprising discoveries is the existence of rogue black holes. These are black holes that have been flung out of their original locations by powerful cosmic events. They now drift through the galaxy silently, their presence detectable only through the subtle ways they walk the fabric of space. Neutron stars add another layer of intrigue, especially those with extreme magnetic fields, called magnetars, which are among the most magnetized objects in the universe. What's truly fascinating is that these remnants aren't scattered randomly. Mapping their positions reveals distinct patterns, shaped by the violent supernovae that created them. Below the solar system lies a graveyard of stars, each a marker of the galaxy's dramatic and turbulent past. But what does this say about our place in all this? Perhaps the most humbling realization is that this cosmic graveyard plays a crucial role in the cycle of life in the universe. The violent deaths of massive stars, though destructive, are also creative. When a star goes supernova, it doesn't just disappear. It explodes and sends out waves of enriched material across the galaxy. These remnants are full of heavy elements like iron, gold, and uranium, forged in the final moments of a star's life. In fact, much of the matter that makes up planets and even life itself comes from these ancient stellar explosions. You, me, the Earth, we're made of star stuff, and much of that star stuff likely originated from deep within this very underworld. It's a poetic irony. In the galaxy's darkest and quietest corners, the seeds for new beginnings are sown. The galactic underworld is not just a graveyard, it's also a cosmic cradle. Adding to the mystery, recent simulations suggest that some of these black holes and neutron stars could be interacting with dark matter itself. Imagine invisible particles surrounding these objects, subtly altering their behavior. This could help scientists learn more about what dark matter really is, and maybe even how it shaped the early galaxy. Moreover, new research hints at the possibility of entire populations of these remnants hiding in plain sight. Some neutron stars, too cold to be seen by traditional means, may still emit faint signals in radio or gamma wavelengths. Upcoming telescopes and missions like the James Webb Space Telescope or the Square Kilometre Array could detect them, revealing just how crowded this so-called underworld really is.
And it doesn't stop there. Scientists speculate that gravitational interactions from the galactic center, or even from passing dwarf galaxies, might have pushed waves of stellar remnants into the region beneath the solar system. These forces may have sculpted this graveyard into specific shapes, ribbons, streams, or shells, preserving a map of ancient galactic encounters written in dead stars. All this leads us to a profound truth. The galaxy beneath us is not just a shadowy mirror of the one above. It's a dynamic, complex archive of cosmic history. Every silent black hole and forgotten neutron star holds clues to where we came from and where the Milky Way is heading next. Understanding the galactic underworld forces us to rethink our solar system's place in the Milky Way. We're not floating in isolation. We're surrounded by the echoes of ancient destruction and creation. Every orbit we complete, we're weaving through a galaxy shaped by forces we're only beginning to grasp. It's a reminder that our cosmic neighborhood is not static. It's alive, evolving, and filled with hidden stories. As we map the heavens, we're not just charting stars and black holes, we're tracing the legacy of the universe itself. And with each discovery, we come a step closer to understanding our true cosmic origin. Another way isn't just a tiny dot floating aimlessly in space. It's part of something vast and intricate. Above us, the Galactic Halo holds secrets of ancient stars and invisible forces, while below, the Galactic Underworld reveals the remains of massive stellar explosions. Together, these structures shape the Milky Way and play a role in the galaxy's story. But this isn't just about understanding space. It's about understanding ourselves. By studying what surrounds us, we redefine our place in a universe bursting with mysteries. What else lies out there, waiting to be found? The journey to uncover it has only begun.